Okay, we are told that cosine theta is negative 3/5. We're in quadrant 3 and we want to find the other 5 trig functions. Now I'm going to be honest, you could do this the way we've been doing it, but we want to try out our new cool identities. And there will be times when you can't use the traditional methods and you'll want these, so it's good practice to do that. So I could draw a picture right here, quadrant 3, and go, okay, well this is negative 3 and that's 5. And I could easily figure out that that's negative 4, and I could get my trig identities from that. But suppose I didn't want to, or I couldn't for some reason. What I'm going to do here is I'm going to use my Pythagorean. So I'm going to use my sine cosine one. So sine squared theta plus cosine squared theta equals 1. So then sine squared theta plus negative 3/5 squared equals 1. So that gives me sine squared theta equals plus 9/25 equals 1. Subtract the 9/25, and this is 25/25. So sine squared theta equals 16/25, or plus or minus 4/5 when I take the square root. Now I look at my quadrant, I'm in quadrant 3. Sine is negative in quadrant 3, so sine theta is negative 4/5. I can then use my reciprocal trig identities. So tangent theta is sine theta over cosine theta. So in this case, that's negative 4/5 over negative 3/5, which is negative 4/5 times reciprocal negative 5/3. Those cancel. The answer is 4/3. So at this point, I've figured this out. And now to go on to find the rest, I can use my reciprocal identities, right? So for instance, coming back up here, if this is cosine, secant has to be negative 5/3. If this is sine, cosecant has to be negative 5/4. And finally down here, cotangent has to be 3/4. So this is just another way to find those same values. This is actually probably harder than the other way, but as I said, you're going to want these formulas later, and it's good to spend some time practicing with them. So as you're looking through, like, why is my math lab doing it such a hard way? Well, they're trying to get you familiar with the formulas, and this is simply a way to do it. But certainly you can do the other way as a check as well, but I would spend some time getting used to using those formulas.